Hello all, welcome to Chemistry Edu channel. Today we are going to talk about the most important concept of the atomic structure chapter, that is electronic configuration. So what is electronic configuration? It is the arrangement of electrons. The arrangement of electrons into various orbitals of an atom. So this is again based on the atomic number. Based on the atomic number Z value, we give electrons into various orbitals of an atom. That is called electronic configuration. Now it is very much important for us to know the electronic configuration of an atom to understand the chemical properties or magnetic properties or the metallic properties like conductivity, etc. So to understand all these properties, we need to know electronic configuration. So there are ways to represent this electronic configuration. First is NLX method. What is NLX method? N indicates the shell number or the orbit number, L indicates the orbital or subshell, and X indicates the number of electrons. Suppose if you want to write the electronic configuration of helium, atomic number is 2. So we write first shell, in that S subshell, and we need to fill 2 electrons into it. So this is the NLX method of representation. The other method is box method. So what is box method? We write the orbital as box and N is as it is. So here you write 2 electrons and above that you mention the orbital, whether it is S or P or D. So most common method is the NLX method to represent the electronic configuration. To arrange electrons into any atom this way, we need to follow certain rules. What are those rules? Aufbau principle or Hund's rule or Pauli's exclusion principle. Let us talk about one after the other clearly. So the first principle is the Aufbau principle, which says that electrons are entering into the atom. The electrons enter into orbitals of an atom in the increasing order of their energy. In the increasing order of their energy. That means we need to first fill the lower energy orbital, then only we need to fill the higher energy orbital. This is the first and foremost principle. This is the Euler's diagram to explain the energy of the orbitals, energy order of the orbitals. So based on n plus L value, whichever has higher n plus L value, that will have higher energy. This is the order given. So 1s orbital, if you consider, for 1s the n value is 1 and L value is 0. So 1 plus 0 is equal to 1. Similarly for 2s it is 2 plus 0, 2. For this it is 2 plus 1, 3. So based on the n plus L values, we decide the orbital is of higher energy or lower energy. So accordingly, 1s is of least energy, then comes the 2s, then comes 2p, then comes 3s, and so on will be the order. This way, as the arrow goes down, the energy is increasing for the orbitals. Suppose if the two orbitals have the same n plus L value, for example, if you consider 3p and 4s, here n plus L value is 3 plus 1 equal to 4 and here also 4 plus 0 equal to 4. So the n plus L values are same for both the orbitals. Then to which orbital the electron has to be filled, we need to look at the n value. So if n plus L value is higher, energy is higher. If n plus L value is same, then whichever has the higher n value, that will have the higher energy. So accordingly, we fill electrons into various orbitals using the Aufbau principle. take a screenshot of this diagram. It will be helpful in your exams. The second most important rule of the electronic configuration is the Hund's rule of maximum multiplicity. This mainly explains the filling of electrons into degenerate orbitals. Now, what are degenerate orbitals? The orbitals in a subshell, with equal energy. The orbitals belonging to a subshell which have equal energy are called degenerate orbitals. Suppose if you look at P subshell has 3 orbitals. What are they? Px, Py and Pz. Now these 3 p orbitals are of equal energy and hence they are called what? Degenerate orbitals. Now according to Aufbau, we need to fill lower energy orbital followed by higher energy orbital. But how about the orbitals with equal energy? Then we need to follow Hund's rule. What is it? Hund's rule states that, definition, what is it? Electrons get paired in degenerate orbitals only after filling with 1 electron each. What do you mean by Hund's rule of maximum multiplicity? Electrons in the degenerate orbitals get paired up only after getting 1 electron each. For example, if you consider carbon, atomic number is 6, electronic configuration is 1s2, 2s2, 2p2. Obviously, these are only 1 orbitals, so you don't have any problem. But if you consider 2p, it has 3 p orbitals. All are degenerate, px, py and pz. There are 2 electrons. So those 2 electrons can either enter into 1 orbital to get paired up, or they can enter into 1 electron each. So instead of getting paired up, because both are of equal energy, they are getting 1 electron each. So Hund's rule of maximum multiplicity explains the degenerate orbitals filling with 1 electron each, which indicates the presence of unpaired electrons or single electrons in the outermost shell. The third rule is the Pauli's exclusion principle. This states that no 2 electrons in an atom can have all 4 quantum numbers same. Suppose if all the 4 quantum numbers are same for a given atom, that means it indicates only 1 electron. For example, if you consider 1s2 electronic configuration. So 2 indicates the presence of 2 electrons. For the first electron, if you consider n, l, m, s values, what is n here? 1, l is 0, m can be 0 obviously, and s will have plus half. For the second electron, if you consider, n is same because it belongs to same shell, l is also same because it belongs to same subshell, m is also same because it belongs to same orbital. But what about the spin? When 2 electrons are there, one has to be with the upward spin, the other has to be with the downward spin. That means one will have plus half, the other will have minus half. So Pauli's exclusion principle states that in an orbital, when 2 electrons are there, one should be with the upward arrow, the other should be with the downward arrow, where the spin will vary for the 2 electrons present in the same orbital. But no 2 electrons will have all the quantum numbers same. N, L, M can be same but not S. This is the Pauli's exclusion principle. Let us understand the stability of atoms or ions based on the electronic configuration. So there can be two types of electronic configurations possible. Either the orbitals can be completely filled or half filled. For example, if you consider atoms like neon, argon, krypton, etc., these are all the inert gases which have completely filled outermost shell. That means they have 8 electrons in their outermost shell. So their s and p orbitals are completely filled up. So they'll have ns2 np6 configuration. If you consider ions like sodium plus, Mg plus 2, O minus 2, etc., they are all trying to lose or gain electrons and attain 8 electrons in the outermost shell, and they also have ns2 np6 configuration. And what is half filled configuration? For example, if you consider nitrogen and oxygen. Nitrogen has 1s2, 2s2, 2p, 3 configuration. Oxygen has 1s2, 2s2, 2p4 configuration. So here the p has 3 electrons, but here the p has 4 electrons, where each orbital is filled with 1 electron here, but here 2 are paired, 2 are unpaired, so there is no symmetry. In such case, you call this as half filled configuration, and you call this as incompletely filled configuration. So half filled configuration is more stable compared to the incompletely filled configuration. So if you take the order, completely filled configuration is more stable than half filled than incompletely filled. So this is about the electronic configuration and its principles. Let us talk about the anomalous configurations. Anomalous configurations are mainly observed in chromium and copper, where the electronic configuration in them is deviating from the expected configuration. So such configurations are called anomalous configurations. So the atomic number for chromium is 24 and for copper it is 29. So according to Aufbau, Hund's and Pauli's principles, we need to write the electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 4 has to be the configuration. This is expected. Similarly, for copper, the expected is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 9 is the expected. But since the half filled and completely filled configurations are very much stable, the observed configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. So 3d5 is with 5 unpaired electrons. Here it was incompletely filled configuration. 4s is with paired, 3d is with unpaired, but here 4s and 3d all are having unpaired electrons. Such configuration is called half filled configuration, which is deviating from the expected, so it comes under anomalous configuration. Similarly, for copper we expect it to be this way, 4s1, 3d10, so where 3d is with completely filled configuration and 4s is with half filled configuration. So this way they are getting extra stability by changing their electronic configuration. Such configurations are called anomalous configurations. So the important questions are, they can ask you like what is electronic configuration, then you need to give the definition for 1 mark, and what are the principles used to write the configuration, then you need to write Aufbau, Pauli's and Hund's, mention the names, you get 1 mark, and explain them with definitions, you get 3 marks for that. So overall this can be given for 5 marks. Or in short, they can give you state and explain Pauli principle, or state and explain Aufbau, state and explain Hund's rule with for 3 marks also they can give you. Or they can ask you the anomalous electronic configurations of copper or chromium, or they can just give few elements like carbon, oxygen, nitrogen, and ask you to write the electronic configuration for 3 marks. So these are the most expected questions from this topic. Thank you.